Welcome back, all my aspiring mathematicians. Today, I'm going to dive into the topic of complex rational expression. Now, what is a complex rational expression? It is simply a fraction that has a fraction in its numerator or denominator or both, and that numerator or denominator can contain whether it's going to be a mixed number with a variable or it's just simply going to be a fraction. So because you have the variable as part of that fraction, then it is called complex rational expression. Let's take you back down memory lane. If you can recall working on complex numbers, then it will be easy for you to understand complex rational expression. The type of problems that you are usually given in the topic of complex rational expression usually deals with a combination of addition, subtraction, multiplication, and division. And for the most part, it is simply you're given a fraction with a number that is going to be added or subtracted from that, and then you have to divide that by another fraction with a fraction and a number where there's a whole number that is being subtracted or added onto that. So let's first show you an example of what it is like just working with just the variables and no numbers, and then I'm going to get into examples with variables and numbers. So let's get right into it. So let's start off first with the one with the variables. So you have the variable here, a squared, and I'm going to put this over b, and I'm going to subtract this by c. This is the numerator, and then we have this division sign here, or the bar. So we are going to have now a minus d over e. So this is basically an example with just the variables, and I'm going to show you what to do first. So the first step in solving this problem is that you're going to solve what is in the numerator first, because this is the numerator, and then you are going to solve what is in the denominator, and then you're going to do your division. So first step is that you're going to solve this, so you have a squared over b minus c. We are now going to write that c as a fraction, and to write it as a fraction, we're going to put it over 1. So because I have that, we are going to follow the step to subtract rational expressions. And if you don't remember how to do that, you can go back and watch my video on how to subtract rational expressions. So now we have our b here, because you're looking at the numbers in your denominator to determine a number that you are going to place here. So once you have that, then you're ready to go. So b into b is simply going to be 1, right? You can have the 1 there, and then you're going to multiply that by the a squared, the number which is a numerator. Bring down your subtraction sign, and 1 into b is simply going to be b. You just have b, and then you're going to multiply that by c. So you will end up with a squared minus bc over b. So that is just what this is going to give you when you have these terms right here. So once you have that, then we are going to move on now to step number 2 here. So this is step number 2. Solve what's in the denominator, and we are going to have a minus d over e, and I must tell you, please write the a as a fraction. So now it's going to be simply a over 1. So you draw your line here, you're going to put e here, right, based on what you have here in your denominator. So 1 into e is just going to be an e times a, which is the a is the variable in the numerator, and then you bring down your subtraction sign, and then you say e into e is going to be 1. You can put the 1 there, but you don't have to. But because there might be students here that is not strong in math, and I have to do these baby steps for you. So you will end up with 1 here, then multiply that by d, and we're going to put this together. So the next line now is going to read as simply, you can put a first, ae minus d over e. And that's what you'll have. for your answer for that. So the third step now is where you are going to combine all of this, and we are going to say now we have the solution here for the first part and we have the solution here for the second part. So we are going to do step 1 answer and divide it by step 2 answer. Alright? So now we have step 1, which was a squared minus bc over b. And then what we are going to do, we are going to multiply that bc, and this is going to be divided by ae minus d over e. Now, one thing I must say to you here, we are going to bring back prior knowledge on how to divide rational expressions. And if you don't remember, you can go back and watch my video here on how to divide with rational expressions. So if you don't remember, I'm still going to help you out. We are going to use the technique of keep, change, and flip. And when we say flip, we are talking about flipping this, getting the reciprocal of that, changing it. What's in the denominator is going to be placed in the numerator, and what's in the numerator is going to be placed in the denominator. So for argument's sake, what I'm going to do here, I'm going to rewrite this part that I have first, which is a squared minus bc over b. And then I'm going to change that sign because I must change my division to multiplication. And once I do that, I'm going to flip my last expression there. So I will have e over ae minus d. So once you have that, like this, you can cross multiply it across or just combine it, and so you will end up with your correct answer. Now this is going to lead you, I'm going to write it up here because of space, right? And you now have e multiplied by a squared minus bc over b times ae minus d. And this is what you would have for this example. So this is just simply an example using just variables. Now I'm going to get into another example where you will have variables and numbers. So let's get right into that example. X plus a quarter over x minus a quarter. And as you can identify, this is a complex rational expression because you have numbers and variables here. In the numerator, right, you have a variable here added on to a number, and you can't just add them like that. So you have to first solve this. This is the addition, and then solve the subtraction, and then do the division. So first thing first, I'm going to do the first step, step 1, which I'm going to take now x plus a quarter. And we have the x here, but we're going to write it as a fraction. Always do that. Now that I have that as a fraction, I can go ahead and just solve it. So I am adding my fraction, so I have 1 here and 4. So when you multiply 1 and 4, you're going to use 4 down here. And then you're going to say 1 into 4 is going to be 4 times. So you have 4 here. And multiply that by x. And then you bring down your plus sign. And 4 into 4 is 1. And 1 times 1 is going to be 1. But for those students who are not versed on math, I always like to go step by step. So now you end up with 4x plus 1 over 4. And this is the part that we're going to use later on in our third step. Step number 2, we are going to use our denominator here. We have x minus a quarter. Now, we must write this as a fraction, all right? And I'm going to put it over 1. And now I have 1 and 4 here. I need to use 4. And so 1 into 4 is going to be 4 times. And then you have times x, so 4x. and then you bring down your minus sign, and 4 into 4 is 1, and 1 times 1 is 1. So now you are going to use this same example, just as is, right, which is the equals to 4x minus 1 over 4 as the answer, right? Now we are going to get into our third step. And step number 3 is that we are going to divide these two that we got. So we have 4x plus 1 from here over 4 divided by 4x minus 1 over 4. Now with this, we are going to still use the concept of keep, change, and flip. KCF or KFC if you're thinking about chicken food. So KCF, which is similar to KFC, if you're thinking about food, finger looking good, then you're going to do your C before your F, because that is the form that it takes also when you are looking at the alphabet. So we are going to rewrite our 4x plus 1 over 4. Then I'm going to change my division sign to multiplication, and I'm going to flip the next fraction. So when I flip it, I'm going to now have 4 on top over 4x minus 1. You must remember to flip it. Flip it like a flipper board. Yeah, flip it. Alright? Meaning, do the reciprocal of it. That's another math terminology. So now we have that, and we can look at what we have here, and we'll notice, hey, we can simply cancel out the 4 with the 4, and 4 into 4 one time, 4 into 4 one time. We can't do anything with this because there's an addition sign here and there's a subtraction sign here. So now this is simply going to give us the answer as 4x plus 1 over 4x minus 1. And you box a cloud around your answer. Remember, you can't do anything to this. You just have to leave it as that. As you should know by now, I always give more than one example. So I'm going to give you another example, and this time you will see something unique about this example. So let's get right into it. So our next example is y over 5 minus 1 divided by y to the second over 25 minus 1. You might be saying to yourself, wow, you have the first part, which is the numerator, that has a fraction and a whole number subtracted by a whole number. And so you have to treat this first and do that one first. So step number 1, as usual, you are going to solve for what is in the numerator. And we will do that subtraction because that's what is happening here. So you have y over 5 minus 1. You can choose to either do 1 over 1 is fine, and then you take it from there, okay? So this is subtracting. So we have our 5 here, and we are going to say, because 5 times 1 is 5, so 5 into 5 is 1 time, and 1 times y at top, and then you bring down your subtraction sign. 1 into 5 goes 5 times, and so 5 times 1 is going to be 5 up there. And now you will end up with y minus 5 over 5. You can't simplify this. No, this is the answer for this part, which is the numerator. Next step is now to solve for the denominator. So for the denominator, it is y squared over 25 minus 1. Once again, you can change this and you can put it over 1, which you know is fine, because 1 over 1 is simply 1. And then you are going to draw your line here, and you're going to use 25. Now 1 times 25, that's why we use a 25 here. Now 25 into 25 is 1 time. 1 times y to the second power is simply going to be y to the second power. Bring down your subtraction sign. 1 into 25 is going to be 25 times. 25 times 1 is going to be 25, and you will end up with y squared minus 25 over 25. Now I must say to you, right, that you can't do anything with this. This is the answer for what is in the denominator. So this third step now is that we are going to divide these. So we are going to take what we got for the answer for this first step, which is y minus 5 divided by 5. And then we are going to divide it by y to the second power minus 25 over 25. Now, I don't know if you can look at this and see that something is happening here. You have difference of two squares going on here. If you don't know how to factor difference of two squares, you can go back and watch my video on how to factor difference of two squares. But if you do, let's get right into it. So I have here y minus 5 over 5, and I'm going to change my division sign here to a multiplication, right? Because that's what you have to do. Key, change, and flip. And then I'm going to flip this, but while I'm flipping this, I'm also going to change what I had in my numerator. I'm going to now put it in my denominator, but I'm going to write it as difference of two squares. So you're going to have y minus 5 and y plus 5. Must do this. If you don't, then you're going to run into problems. Okay? Now you can go ahead and we can cancel out where necessary. So we have 5 into 5 is 1. 5 into 25 is going to be 5 times. Make sure you put that there. And don't ever not put a number here and tell me, oh, it's 0. Or you just cancel it out and that's it. No, that would not be the case. Then y minus 5 is 1. Y minus 5 over here cancel out, which is 1. That's why I'm putting the 1 here. So your answer now is going to be 5 over y plus 5. And that is your final answer for this particular problem. Now that you know how to solve complex rational expressions, I hope that you do realize that it is a combination of adding rational expressions, multiplying rational expressions, subtracting rational expressions, and obviously also dividing rational expressions. Because if you notice, when you were doing the division, you have to follow the same steps as key, change, and flip in order to get the correct answer. So don't forget that. So these problems, always think ahead and say, oh, if it is complex, that means, guess what? A lot of complex things going on. A lot of things, if it is complex, then that means that a lot of things is going on in this problem. And because it is a complex rational expression, so you have the addition going on of the rational expressions, which you need to know how to do that, and you can go back and watch my video on that. Also the subtraction, right, of rational expressions, the multiplication of rational expressions, and the division of rational expressions. So pretty much when it comes to this topic, you have to have already know how to creep, and then you get up now and you're ready to walk. You see a complex rational expression, I want you to think outside the box. I want you to think further and say, hey, it is a combination of adding rational expressions, subtracting rational expressions, multiplying rational expressions, and dividing rational expressions. So you have to combine all of that prior knowledge into this one type of problem. And guess what? It's like taking baby steps, and then you're able to walk. So you're taking these little baby steps and you're creeping also, and then you're going to get up and you're going to walk. So complex rational expressions is simply prior knowledge, things that were taught to you before, and you're combining them into these problems and solving them to get your answer. So with that being said, I hope that this video has helped you tremendously. And now that you know how to solve complex rational expressions, you will not leave this to yourself. And if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And while you're at it, hey, hit the like button. Hey, and guess what? We're not going to be selfish. We're going to share this with others around the world so they too can be successful when it comes to problems dealing with complex rational expression. And don't forget, leave a comment. I like to read your comments, And if there is a particular video that you would like me to do, please state it and I will honor your request. Thank you for watching and see you soon on the next video to come. Bye now.